Good morning. We're going to talk about the product rule today and working with exponential expressions where we have the same base. And let me go and show you the product rule because it's actually written on the page for you here. And it is right, let me highlight it right here. And see how we have a to the m power times a to the n power equals a to the m plus n power. That's what our lesson is all about today. And you'll notice over here on the side I have written that this goes with your class notes, pages 4 through 8. So go ahead and get out your class notes and take notes along with me on pages 4 through 8. And as we go through these, I'll tell you what problems relate to each kind that we do so you know what you're doing. First of all, with this rule, I want to show you why it works. And we're going to go to this example right here. I have 3 to the 4th power times 3 to the 2nd power. And 3 to the 4th power is 3 multiplied by itself 4 times. And 3 to the 2nd power is 3 multiplied by itself 2 times. And if we multiply these together, you can see that I have 3 multiplied by itself 6 times. All right, and notice that the 6 comes from the 4 plus the 2. So I didn't have to write this all out longhand like is written here. I could just add the 4 and the 2. Now notice something. The 3 does not become any other number. It stays a 3. So something to keep in mind as we go through these examples. That base always going to stay the same. Okay, let's use our new product rule, and we're going to simplify some expressions. You'll notice here at the bottom of the page that I've written that this goes along with page 429, numbers 8 through 13. So after we do these examples, you'll be able to do those problems from your homework. Let's point out this rule again because it's really important here. A to the m times a to the n power equals a to the m plus n. Notice that a is the base. Have to have the same base in order to get this rule to work. If you don't, can't use it. So let's go here to example A. And in example A, notice I do have the same base. I have 12s. So I can use this rule. So this is going to equal 12 to the 4 plus 3 power, which will give us 12 to the 7 power. In the second example, I've got negative 5 as my base. So I can rewrite this, keeping my negative 5 in parentheses. Add my exponents. I've got negative 2 plus 7. That's going to give me positive 5. So this is negative 5 to the positive 5 power. In example C, notice I have 8s as my base. Bring over my base of 8, and it's to the power of 3 plus 6, which is 9, which gives me 8 to the 9th power. I can even do this with 3 expressions. Notice, same base, they all have 9s, so I can go ahead and write this as 9 to the negative 3 plus 2 plus 6, and I think that gives me positive 5 equals 9 to the positive 5 power. Now we're going to work on some more complicated problems. One thing to keep in mind, when we're doing this with variables, you can only combine those terms that have the same base. So if you're working with different variables, you may have different bases and you can't really combine them. Keep in mind as you look at the bottom of the page, this goes with page 429, numbers 14 through 19. So let's go ahead and look at example A. First thing, we have some coefficients, a 4 and a 9. You can go ahead and multiply those. So I'm going to get 36, and my base is the same. I have z's, so z, and then I have 5 plus negative 12. And notice that's going to give me a negative 7. So this is going to give me an extra step. So I've got 36 z to the negative 7. But what did we learn in our last lesson? We don't want to leave negative exponents. So what we're going to do with this, remember from last time, move that below the fraction bar. Not the 36 though, that doesn't have a negative exponent, only the z. So here's what we'll have. We'll have 36 over z to the positive 7 power. Let's go to our next example, and we can multiply our coefficients. We have a 2 times a 9 times a 3. I like to do this in an order that's easy for me. I'm going to do the 2 and the 3. That gives me 6. 6 and 9 is going to give me 54. So I'm going to start out with a coefficient of 54. Now notice I have some A's, I can combine those, but my other term right here is a B. I cannot combine that, I gotta leave it separate. So I have A, and the exponent that I don't see here is a 1. So the 1 plus 2 power, and then b to the 4th. So this is going to give me 54, a to the 3rd power, b to the 4th power. If I go to my next example, it's really just a multiplication problem written with parentheses instead of dots. Same thing though, multiply my exponents, and I've got a 5 and a 3. That's going to give me a 15. I've got x's, x's, x's. I'm going to add up those exponents. So I've got 4 plus 9 plus 1, and I think that's going to give me 14. So this will give me 15x to the 14th power. Go to the next one, multiply my coefficients. -4, I'll multiply it times the 2, gives me -8, times the 7 is going to give me -56. I've got some c's, and then the d's are going to have to stay separate. So I'm going to have c to the 3 plus -2 power, d squared. This is going to give me c to the 1 power, and I don't have to write the 1. So I can just write -56 c d squared. Another example, multiply my coefficients. I just have 12s and 1s, so I'm going to have 12. I can combine my j's, but not my k. So I'm going to have j to the 2 plus the 1 power that we don't see, and then I have k to the -2 power. And let's go simplify that. Gives us 12 j to the 3rd power, k to the -2. Remember, we don't want to leave negative exponents. Move those k's to the bottom. Everything else stays right where it is. So on top, 12 j to the 3rd over k squared. And my very last example, this may look kind of confusing because we have no numbers whatsoever, but we do have the same base. Just add those exponents. So believe it or not, this is x to the power of a plus b plus c, and you are done. This problem is going to be like the ones you need to do from page 430, number 39 through 41. If you take a look at this, this is a story problem, which is probably going to confuse a number of you. If you want to go ahead and read it in your notes, that's great. Really, all you have to do is multiply these two numbers. Now, these two numbers are written in what we call scientific notation. In scientific notation, what we want to do is have our first numbers here always want to be between 1 and 10, and then we're going to have times 10 to some power. And what this is used to represent is either very, very large numbers or very, very small numbers. So in this case, this is a very, very large number. If we look at the 9.98 times 10 to the 5th, just so you know, let's go get us a new color over here. Really, 9.98 times 10 to the 5th means move that decimal point 1, 2, 3, 4, 5 places. So we're going to fill in with some zeros. Really means 998,000, but it's just a different way of writing it. Now when we go to multiply these, this is pretty easy. We're going to take these two numbers here and we're going to multiply those, and we're going to get 33.33. And then we're going to take these and multiply them. We have the same base. So 10 to the 5 plus 22, which is going to give us 33.33 times 10 to the 27. Now, I've now violated the rule of scientific notation, which is that this number right here needs to be between 1 and 10. So what I'm going to do with this is I've got to fix it by moving my decimal. So I'm going to move my decimal one place over here to the left. When I do that, I'm going to have to add one more to my exponent. So essentially, I've got to multiply by 10 one more time. This is going to give us 3.333 times 10 to the 28th power. All right, the next thing is a little bit confusing at times, but it's something that we need to really understand. We could have exponents that are fractions. And I'm going to show you one in the middle of the page right here. We've got this one, 9 to the 1/2 power. 9 to the 1/2 power really means the square root of 9. So this is 3. And the reason it's 3 is because 3 times 3 equals 9. So what it's really saying to us, that 1/2 power, is what multiplied by itself twice will give me the 9. And so that's what that means. And so here's our general definition. A to the 1 over m equals b power means that b multiplied as a factor m times equals a. We're going to go ahead and just do a couple of quick examples here. 81 to the 1/4 power means find the number when multiplied by itself 4 times gives 81. And that is going to be 3. And the reason why I'm going to put b/c for because 3 to the 4th power equals 81. All right, so these are some that you might want to think about memorizing, because I will tell you, you will need to do it in Algebra 2. Okay, so the next one, 16 to the 1/4 power. So what multiplied by itself 4 times gives us 16? That would be 2. And the reason why is because, should be see there, 2 to the 4th power equals 16. 27 to the 1/3 power. What multiplied by itself 3 times gives us 27? That would be 3, because 3 to the 3rd power gives us the 27. And 64 to the 1/2 power, that means what multiplied by itself twice gives us 64? That would be 8. And the reason why is because 8 squared equals 64. Okay, let's go to the next example. In these examples, you notice they're like the last ones, but our numerators are not ones. So here's what we have. We have 64 raised to the 3/2 power. What I want us to do is write 64 to the 1/2 power 3 times. And the 3 times is because of the 3 in the numerator. And I hope you'll agree that 1/2 plus 1/2 plus 1/2 gives us 3/2. Now we just did this example on the last page, and we know that 64 to the 1/2 power is 8. So this is 8 times 8 times 8, which gives us 8 to the 3rd power, and that would be whatever that equals. In the next example, we have 25 to the 3/2 power. Well, that 3 in the numerator means let's write 25 to the 1/2 power 3 times. So 25 to the 1/2 power multiplied 3 times. So 25 to the 1/2 power equals 5, because 5 to the 2nd power equals 25. So this is going to be 5 times 5 times 5. I can do this one in my head, equals 5 to the 3rd power, which gives us 125. In the last problem, I've got 27 to the 2/3 power. That means I'm going to write 27 to the 1/3 power 2 times. We did this one on the last page. What this means here is what multiplied by itself 3 times gives us 27, and that is 3. So this is 3 times 3, which gives us 9. In our next example, we've just got some more complex problems. Note that this goes with page 430, number 28 through 30. Hopefully, as you've been going through this video, you stop after each page and do the problems that go along with it that are assigned for today. I'm going to show you how to do this, same as before. It's just that we have some fractional exponents. And so first thing I'm going to do, 2 times 3 is going to give me 6. And here's my base of 3, so I have C to the 3/5 plus 1/5, and 3/5 plus 1/5, I do have a common denominator of 5, so just add across the numerator is 6c to the 4/5 power. Now because I don't have a number here, there's nothing I can do to simplify this, and we are done. If you take a look at example B, this looks much more complicated, but really it's not too bad. We're going to combine the things that go together. So first, all of our coefficients. 2 times 3 is 6, times the 5 is 30. Now, I've got some A's. I'm going to put those together. And I've got some B's. I'm going to put those together. So A, and I'm going to have 2/3 plus 1/3. And for my B's, I have 1/4 and 1/2. One thing to keep in mind as you are doing this, when you're adding exponents that are fractions, you are going to need a common denominator. So if you take a look right here, you have one, but here you do not. We need to multiply the top and bottom of this fraction by 2 so that we have 2/4 and that we can now add these together. This will give us 30. This is A. 2/3 plus 1/3 is 3/3, which is just 1. All right, so this is just 1. We don't need to write it. B, 1/4 and 2/4 gives us 3/4 power. Hope you're having a great day.